I got up very early today, and it was a hard day. But we'll see how we go, mate, for the for the callbacks. But I will listen to as much as I can of your highly valued, educational and entertaining report. Good on you there, Clint, and we'll catch you on the other side. VK3 CSJ, VK3 BKO.
Yeah, no worries, Brendan. Look, I've got a few things. I'll probably fill up the hour without a problem. There's a couple of interesting things, particularly some video footage of a recent earthquake. I think it'd be interesting to see by others. I've just started the YouTube stream, so that's currently running. Hopefully, it'll won't fall over when I come up on 80. But I'm going to try and make it a short broadcast if I can, because I've got to start work at 6 o'clock in the morning. They've got me working overtime tomorrow, so it'll be a short session, I hope, but I bet you it won't. Anyway, we'll see how it goes. Anyway, I'm on YouTube right now, and I'll better fire up the repeater and get that warmed up, and we'll be back in 7 minutes.
Yeah, roger that there, Clint. Just one thing, mate, and then I'll let you go get your coffee. If you want to turn your squash right up so it's just underneath me, mate, I can let you know if we lose the feed there, mate. But I think you have a monitor monitoring it anyway, don't you?
What, monitoring YouTube?
Yeah.
Yeah, I don't. The only thing that tells me that I'm streaming is the indicator on vMix. The two video streams that I've got going, Discord and YouTube, there's two icons at the bottom of the page that are red. And if I see red, that tells me that I'm streaming and everything's okay. If they change colour, I know that I've fallen over. The internet's fallen over. So I generally know when I've got trouble with the stream, because I lose that connection. But hopefully it'll be okay. Normally, when I was upstairs with the Radio Shack, I used to have other monitors around me that I used to monitor the YouTube stream, and I used to monitor just about everything else too. But since I'm downstairs here, I've only really got the one monitor set up, so I haven't quite got everything quite the way I want it. Anyway, it's I think she'll be right. Hopefully, it'll be right.
Any longer, mate, but yeah, have a great net, and we'll catch you later on down the track. But yeah, I'll try to get on more. I've missed too many reports that I really enjoyed. But anyway, all right, mate. 7-3 for now. CSJ, VK3, BKO on the side and listening and watching YouTube.
Thanks, Brendan. Catch you soon. VK3 CSJ Clip. One, two. Good evening. This is VK3EKH, VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria, with the regular Friday night broadcast coming to you from the studios of VK3 Charlie Sierra Juliet in Narre South, broadcasting on prime frequency of 3541 kilohertz in the 80 metre amateur radio band, and also via the Melbourne television repeater, VK3 RTV, digital channel 1, full HD, and also broadcasting on my YouTube stream. Just type in VK3CSJ in the YouTube search engine and look for the live indication, and I hope that the streams won't fall over due to RF getting into the modem. And there's also my Discord channel. If you haven't registered on Discord, it's just a simple matter of registering, and as I always say, when you do register with Discord, there is a password that you have to enter, your own personal password, and don't forget it, because even if you don't come back to Discord for a few weeks, months, and you think, oh yes, that's right, I've got Discord, and you go to log in on Discord and you've forgotten your Morse code, you've forgotten your password, it's a bit of a job to try and resurrect or reset your password, I have been told. So for some reason, Discord isn't all that easy if you forget your password. So don't forget your password when it comes to Discord. But nevertheless, on my QRZ.com page, VK3CSJ and VK3EKH, I provide a universal password that allows you to be able to get to my astronomy channel, what we call the astronomy chat room, and the HD stream, which basically is running all the time. Unless I've got Discord closed, I usually run all the time. It's a bit different to YouTube. With Discord, I'm not recording any video, it's just streaming, whereas with YouTube, it tends to record the transmissions. So nevertheless, the thing, what I'm aiming at is that the YouTube Discord is far better, because apart from the fact that it's HD, the delay between what you're hearing direct here on 80 meters and what you see on Discord is virtually less than a second. So it's more appropriate to when you're listening to me here on 80 and showing and talking about videos and graphics, and you can watch on Discord in real time, more or less. Whereas with YouTube, there's anything up to a 20-second delay. So if you don't mind the 20-second delay to what you're hearing here, then that's fine. But I do recommend Discord, just registering with Discord. There's no funds involved. It's just simply a matter of registering so you can log in and log out and all that sort of stuff. And Discord is the way to go. Yeah. With YouTube, I'm not fussed about subscribing or clicking here. You know, every blasted YouTube that you go to, they interrupt what they're saying with, oh, don't forget to subscribe and click the bell if you want to get updates. You know, that's a lot of wank. So don't worry about that for me. I'm just broadcasting a YouTube stream because it's an addition to all the other videos that I run here. All right, now, before we go on, let's go with the usual blurb about the society and get that out of the way, because there's a few things tonight. I've got to make tonight relatively short. I doubt that I will, but I've been told to do a little bit of work tomorrow, so they've got me coming in at 6 o'clock in the morning. I've got to start work at 6, so I've got to be up before 5 o'clock, which is even worse than it normally is, but there it is. So it's an early night is what I'm saying. Right, I think I'm on. Yep, I am. The Astronomical Society of Victoria was founded in 1922, comprises well over 1,600 members scattered about Victoria and Australia and overseas. Membership of the Society is open to all persons with an interest in astronomy. The Society's objectives are to encourage the study and practice of astronomy, to disseminate the knowledge of the science, and to provide greater facilities for the study among its members. Monthly meetings are usually held on the second Wednesday of each month, and meetings start at 8 p.m. at the Morley Hall in Burwood Avenue, Melbourne, near the Melbourne Observatory, which is located not too far from the Shrine of Remembrance. Parking is available in Burwood Avenue, Delos Brooks Drive, and the surrounding streets. Admission is free, and visitors are most welcome. These monthly meetings usually start right on the noggin at 8 o'clock and aim to finish at 10 o'clock. There's usually a little free supply of tea and coffee after the meetings with a few little bickies, and the ASV library is also open as well after those meetings for about half an hour or so. Apart from all that, privileges of membership include the right to borrow books, periodicals and publications from the Society extensive library located at Melbourne University, Melbourne Observatory actually. Receipt of the ASV's magazine Crux containing articles, news, observing notes and the like, and the free provision of the Astronomical yearbook. Access is available to telescopes on members' nights held regularly at the Melbourne Observatory and after monthly meetings, weather permitting. These instruments include the Society's 300mm equatorial reflector and a 300mm portable reflector. There's also a 200mm refractor managed by the Royal Botanic Gardens, and a photoheliograph are also housed at the observatory and are accessible to members as well. The Society also has a number of 200mm reflectors available for short period loan through the through the telescope loan scheme. Regular Society Club Night meetings are held at Melbourne Observatory and in the Ellery Suite, Burwood Avenue, opposite the Shrine of Remembrance. Members are encouraged to use the Society's instruments located there in order to gain first-hand experience in telescope use. These instruments include a 508mm equatorial reflector and a number of smaller reflectors. Oh boy. Members are also encouraged to make use of the Society's country property located near Heathcote, some 90-minute drive north of Melbourne. There are a range of instruments available for members to use, the larger two with appropriate training, which range from 300 to 1000mm in aperture. Also located on the site is a fully steerable radio telescope, 8.5 metre, which members can access with involvement in the radio astronomy section. Members are encouraged to make and use the telescopes in general. Advice and help on both matters are provided willingly to newcomers desiring to do the same. Instrument making is only one of the number of common interest activities catered for within the Society. Other areas of interest that the members can participate in include deep sky observing, astrophotography, lunar and planetary observing, auroral, meteor, comet and radio astronomy, computing, cosmology and astrophysics are all catered for. Historical studies and research in astronomy in general. Contact details for various section directors are provided in the yearbook. Further information may be obtained by visiting the ASV website at www.asv.org.au. That's www.asv.org.com.au. And or you can write a letter to the Secretary, address the envelope to the Secretary, Astronomical Society of Victoria, GPO Box 1059, Melbourne, Victoria 3001. Please note that the ASV will conform to all government health directives, and thus ASV events may be required to be cancelled, moved or postponed as a result. So all information basically can be gleaned from the ASV website, courtesy of therefore and everything else. All right, I'm going to zip along tonight because there's a few interesting things, I believe. But I want to try and keep the session a little on the short side. So it all depends on how quick I read. No, not really. All right. Let's see. You're tuned to ASV Radio, VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria, broadcasting since 1988, and heaven knows how long it'll continue. All right. And I think I'm still streaming. Let me check my indicators. Yep, still there. Let me also check just to see who's on YouTube, as in Discord, and I see that I'm there. I can also see that Mike VK1UEB is there. G'day, Mike. Mr. Steve 3SBX. G'day, Brett VK2CBD. Sam VK3FST, and g'day, Mike VK3XL. Welcome to the Discord stream. Discord, YouTube. We do have an email address, so I should really mention that too, because I haven't yet. I'll just open up the inbox first of all. Let me see. VK3EKH at gmail.com. Stay steady. VK3EKH at gmail.com. So I'll just monitor that inbox every now and then. Now, the first thing I was going to talk about, it's a short article, but if you're interested in being able to see astronomical objects in the sky, it's generally called how good the seeing is, as in how well you can see astronomical objects, and a lot of things can affect the visibility factor. This article is to do with the relative humidity. And the title of the article, courtesy of astronomy.com, is dew point or relative humidity more important for good astronomical seeing? And it really depends on the higher levels of our atmosphere, but lower dew point is generally considered better starting point for good observing of the sky. There is actually an image associated with this article, so I'll bring that up first for you folks to look at while I'm chatting away. And can I bring up, where's my insert? There's my insert. Okay. Basically, the article is, it's the question, actually, it's one of these question and answer things. Actually, what's on the screen right now is this is a view from the GOES East Satellite Band 8, shows the atmosphere above the continental US imaged at 2.6 microns in the infrared portion of the spectrum on midday Jan 3rd, 2025. Images at this wavelength show water vapor in the upper troposphere. Red and yellow colors indicate dry air, although not present here. Blue indicates moist air, and white and green colors show clouds. That's what you're looking at there. The question is, he says, this fellow from Michigan, he says, I've long wondered whether dew point or relative humidity is more important for good seeing. Which would be better, a cool night with low dew point but higher humidity, or a warm night with high dew point but lower humidity? Question mark. The answer to that is dew point and relative humidity questions come up fairly often, and this is a good one. Water vapor in the atmosphere is pretty important for deep sky observing and photography. The atmosphere can only hold a finite amount of water before it becomes full or saturated. That amount is somewhat flexible. It is possible to be oversaturated, but the definition is good for our purpose here. The problem is that the amount of water a sample of air can hold depends on temperature. Relative humidity, or RH, is a comparison between the actual amount of water in the atmosphere and how much would be needed to saturate it. If you have 80% relative humidity, then the air is holding 80% of the water that it could at that temperature. It's kind of like a bucket that's 80% full at one temperature, except that the bucket would grow larger as the temperature goes up and shrinks and shrink when it falls. The amount of water wouldn't change. Dew point is the temperature at which the moisture in the air would condense and supposedly form dew or frost on a telescope. To belabor our example, it's the point at which falling temperatures would shrink our bucket to the point where the contents overflowed. In practice, dew point is a more stable measurement of water in the atmosphere. It measures the absolute amount of water rather than the relative amount of water. For example, and there's another graphic here that we're going to make reference to. Let me just bring that up. There it is. So they're going to say here that, for example, a sample of air that is saturated to 4 degrees Celsius and one that is saturated at 26 degrees Celsius both have relative humidity of 100%. But the sample at the higher temperature has 3.5 times as much water as the cold sample. Both are filled when saturated, but one contains more water. Now, consider the dew point. Let's say that both samples are in same sized buckets and have dew point of 0 degrees. That's a relative humidity of 73% for the cooler sample and 23% for the warmer. Both will reach condensation at the same temperature, and at 0 degrees, air has a moisture content of 0.09 pound per square inch, or 0.006 kilogram per square centimetre, or 6.11 millibars. Those look like strange numbers, but that's because moisture content is usually expressed as vapor pressure, the pressure that water molecules contribute to the total atmospheric pressure. The units don't matter, but what matters is that the number is the same for both samples. In other words, they both have the same amount of water vapor, and if our 2 buckets were cooled to very cold temperatures, they would have the same amount of ice on the bottom. So dew point is a proxy measure of the actual amount of water in the air by weight or pressure, while relative humidity is a measure of the fractional amount of vapor. It's all very complex, isn't it? Winter and summer nights often have relative humidities that reach close to 100% by morning, if not well before. Yet winter nights are often brilliantly clear, while summer nights can be hazy. Dew point is better at telling you when your optics will acquire a coating of moisture, since your telescope is usually colder than the air around it, and the dew condenses first, where it least is wanted. If you have a regulated dew heater, you want to measure what's up against the telescope, not what's in the air around you. However, from an observational point of view, it's not the water near the ground that's the problem, it's the total amount of water vapor above you. To assess that, the author says here, I look at the water vapor satellite images that are available online, such as the it's a URL that's expressed here. I won't worry about the URL. Apart from the fact that they're talking about a satellite image, there are several choices of water vapor images, but he says, I like the high level one. Just check the image before you go out to observe and see if the air is dry in the upper atmosphere that's coming toward you. If so, and if it's otherwise clear, plan on doing your best photography or reaching for the faintest objects for that night. You might also plan on using a dew heater because low water vapor content means that the night will cool quickly. If you are a planetary observer or a photographer, high relative humidity or dew point near the ground may be an indication that the air is under an inversion and stable and seeing is superb. So it's not always one or the other. Most observers know that nights with a thin fog are often the best for teasing out detail in Mars, Jupiter and Saturn. So to answer the question, it really depends on what's going on higher up in the atmosphere, but a lower dew point is a better starting point for good observing. In reality, both cool and warm nights will reach near 100% relative humidity at some point, but the colder air would contain less water. Wow, there it is. So, I mean, I'm just about to get into doing astrophotography, and I need to get a bit of a grip on on understanding relative humidity and water vapor in the air above me. And in general, the winter nights tend to be probably the best for doing astrophotography because the air is cooler, less haze, and the sky directly above tends to be the clearest and better for photography. And that's one of the reasons why I read that article out, if you understood it or not. But that's courtesy of Astronomical.com. It's a current article. It's just up there on the under the news tab. Actually, it's under the Ask Astro tab. If you open up Astronomy.com, across the top there's Ask Astro, and I'm always checking Ask Astro because generally they're interesting questions, and the answers are generally fairly quick. That one there was a little bit involved. Anyway, I thought I'd throw that in just to kick things off and get the vocal cords warmed up. You're tuned to ASV Radio VK3 EKH. All right, now as a bit of an update on our failed Soviet spacecraft that returned to Earth on Saturday, and there's a beautiful image of Venus here, and I'll just bring that up on the screen so you can all gawk at that. Isn't that gorgeous? I'll get rid of me there. No, not that one. Yeah, there we go. All right. Courtesy of Astronomy.com again, debris from the 50-year-old probe Cosmos 482 crash-landed into the Indian Ocean over the weekend. And after failing to make it past Earth orbit on March 31, 1972, the remains of a Venus mission launched by the former Soviet Union circled our planet for years and was given the name Cosmos 482. While the rocket stage and other pieces returned to Earth weeks later, the lander itself made an uncontrolled landing in the Indian Ocean over the weekend. According to a statement from Russian space agency Roscosmos on a telegram, the craft was tracked to a region in the Indian Ocean just west of Jakarta, Indonesia. On Saturday, May 10 at around 2:24 a.m. EDT, or 9:24 a.m. Moscow Standard Time, the European Space Agency confirmed this after noticing that Cosmos 482 was not at the expected orbital position over Germany an hour later. The USSR's Venera, meaning Venus in Russian, program consisted of over 16 probes, landers and orbiters from 1961 to 1983. The Venera 8 probe lifted off on March 27, 1972 and landed on Venus' surface 2 years later, which was the goal. However, its companion mission that launched 4 days later was not so lucky. After the rocket carrying the probe attempted to boost itself into a Venus transfer trajectory, it separated into 4 pieces in an Earth orbit. After the accident, it was given the name Cosmos, the title given to the intentional and unintentional objects left in orbit by the USSR starting in 1961. And there's a picture of this object as well, so I'll just throw that up as well. There it is. At the end of the day, a 3-foot or 1 metre lander was designed to withstand the heat of re-entry and descending through the hot Venetian atmosphere. Jonathan McDowell, an astrophysicist at the Harvard-Smithsonian Center of Astrophysics who had been tracking the object for 25 years, said in an email Monday that he believes it would have survived plunging through the Earth's atmosphere, remaining intact until it made a crash landing at something like 320 kilometers an hour. Even though the Russian government has jurisdiction over the object, it is unlikely to be recovered from the vast reaches of the ocean. So what will happen to the 53-year-old probe now, you might wonder? Well, what happens next is nothing. Since it didn't land anywhere, somewhere where it could be retrieved, we just move on and wait for the next exciting thing falling from space, explains McDowell. The odds of being hit by a piece of space debris are small, but growing. If the current practice continue, the probability of death resulting somewhere in the world over the next decade from being struck by a re-entering rocket body is on the order of 10%, according to a 2022 study published in Nature Astronomy. So yes, it'll be quite fun to be hit by something falling from the from orbit. Struth. All right. Where's my camera? Okay. You're tuned to ASV Radio, VK3 Echo Kilo Hotel. Time is 10:25. And here is a quick report from space.com. And this one's called NASA Resurrects Voyager 1. We keep hearing about these little resurrections from Voyager 1 and Voyager 2 and Pioneers. But anyway, this is current. This is only published about 13 hours ago. Courtesy of space.com. NASA resurrects Voyager 1 interstellar spacecraft's thrusters after 20 years. These thrusters were considered dead. And of course we have the favourite graphic for our Voyager, so I'll just throw that up. There's something different to look at, and I'll might as well bring me in there. Yep, all right, that'll do. So this is a nice, relatively short article. Yep, okay. NASA engineers have miraculously revived the Voyager 1 interstellar probe's backup thrusters, components that hadn't been used since 2004 and were long considered fully defunct. This remarkable feat became necessary because the spacecraft's primary thrusters, which control its orientation, have been degrading due to residue buildup. If the thrusters fail completely, Voyager 1 could lose its ability to point its antennas toward Earth, therefore cutting off communication with Earth nearly after 50 years of operation. To make matters more urgent, the team faced a strict deadline while trying to remedy the thruster situation. After May 4, the Earth-based antenna that sends commands to Voyager 1 and its twin, Voyager 2, was scheduled to go offline for months upgrades, but this would have made timely intervention impossible. NASA's twin Voyager spacecraft launched in 1977 with the primary mission of exploring the outer planets of our solar system, but upon accomplishing the original goal, the Voyagers were then focused their attention on the study of interstellar space. Voyager 1 exited the solar system in August 2012, followed by Voyager 2 in November 2018. Together, these spacecraft have travelled more than 29 billion miles, or 46.7 billion kilometres, making them the farthest human-made objects from Earth, and, along the way, they've provided unprecedented insights into our solar system. While both Voyager spacecraft remain operational, however, their age and immense distance from Earth have brought about significant technical challenges. The radioisotope power generators that keep them running gradually weaken each year, forcing NASA to recently shut down instruments and heaters to conserve energy in order to push the spacecraft systems beyond their limits. Voyager 1 also experienced a recent data glitch caused by a faulty chip. Engineers resolved this with a clever software workaround. Yet despite these hurdles, the Voyagers continue to function, a testament to both the robust design and the ingenuity of the teams managing them. This recent development, in which NASA engineers revived Voyager 1's long-dormant backup thrusters, marks yet another remarkable feat of engineering and offers another lifeline for the aging spacecraft. The backup thrusters are essential for executing precise roll maneuvers that adjust Voyager 1 orientation, ensuring its antenna stays pointed toward Earth for reliable communication. The spacecraft's original roll thrusters failed back in 2004 after two small internal heaters, crucial for their operation, lost power and stopped functioning. After thorough assessment, engineers determined these heaters couldn't be repaired remotely, prompting them to switch reliance fully to the backup thrusters to maintain alignment of the star tracker, a key instrument that helps Voyager 1 navigate and stabilise itself in space. The author here says, I think at that time the team was okay with accepting the primary roll thrusters didn't work because they had a perfectly good backup. The Voyager mission manager at NASA's Jet Propulsion Laboratory, which manages the mission for the agency, said in a statement, and frankly, they probably didn't think the Voyagers were going to keep going for another 20 years. To solve the problem, NASA team had to reactivate Voyager 1's long dormant backup roll thrusters and then attempt to restart the heaters that keep them operational. If the star tracker drifted too far from its guide star during this process, the roll thrusters would automatically fire as a safety measure. But if the heaters weren't back online by then, firing the thrusters could cause a dangerous pressure spike. So the team had to precisely realign the star tracker before thrusters engaged. Because Voyager is so incredibly distant, the team faced an agonising 23-hour wait for the radio signal to travel all the way back to Earth. If the test had failed, Voyager might have already been in serious trouble. Then on March 20, the patience was finally rewarded when Voyager responded perfectly to their commands. Within 20 minutes of receiving the signal, the team saw the thrusters heater's temperature soar and a clear sign that the backup thrusters were firing as planned. It was such a glorious moment. Team morale was very high that day. Todd Barber, the mission's propulsion lead at JPL, said in a statement, "These thrusters were considered dead, and this was a legitimate conclusion. It's just that one of our engineers had an insight that maybe there was this other possible cause, and it was fixable. It was yet another miracle, save for Voyager." This achievement highlights the ingenuity and problem-solving skills of the engineers keeping Voyager operational nearly after 5 decades. Despite the technical hurdles and spacecraft's age, Voyager 1 and 2 continue to send valuable data from beyond our solar system. Their ongoing mission offers a unique opportunity to deepen our understanding of interstellar space and knowledge that no other spacecraft has been able to provide thus far. So I think perhaps one of the most intriguing things about the whole Voyager, these distant probes, is that the signal continues to get weaker and weaker. The Deep Space Network tracking stations that keep an eye on these satellites, the feebly weak signal that comes back and hits the dish and receiving systems is so weak, and yet we're still able to communicate and receive data. At some point, the signal will just be into the noise, and then it won't be usable at all. Be interesting to see how long that'll be. Anyway, you're tuned to ASV Radio, VK3EKH. There's a couple of videos. Tamitha Skove, our space weather woman, she's got a new video which I'll run in a minute. And then there's a video of an earthquake, which was really amazing footage, if you haven't already seen it. And that goes for about 11 minutes. So it's 10:33. This article is short, but it is interesting too. So I'll bring up the picture that I've got here. That's actually a video, but I'll run that. I don't think there's any audio associated with that. I hope there isn't. Oh, 1 2 1 2. Yep. Okay. So just watch this video while I read the article out, and I'll put it on a loop. Now, and all right. This galactic bone was smashed by a pulsar clock up to 20 million miles per hour. What are we talking about? Okay. The culprit in a cosmic hit and run that resulted in a broken bone has been found out. Of course, it's not actually a bone at all, but a mind-blowing huge filament in the center of the Milky Way galaxy known as the Snake, extending for a length of 230 light years. One of the interesting things about this filament is that it's relatively smooth, except for two prominent kinks or breaks. The origin of the fractures in the Snake, which is referenced as G359.13, was something of a mystery. Observations using the Chandra X-ray Observatory and the Meerkat radio telescope revealed the culprit of one of them. Zooming in on one of the fractures identified a prominent point-like source of X-ray and radio waves. A team of astronomers led by Farhed Yousafzadeh of Northwestern University in the US thinks it could only be a radio pulsar that punched through a filament at an absolutely breakneck velocity between 500 to 1,000 kilometers per second. This, believe it or not, is not unheard of for pulsars. That's because pulsars are dead stars, the collapsed cores of massive stars that have reached the end of their lifespan and sneezed off their outer material in a violent supernova. The core of the star, no longer supported by outward pressure of fusion, collapses under gravity to form a neutron star that, when it pulses with light, we call a pulsar. If this supernova is lopsided, the neutron star can be booted unceremoniously across the galaxy at high speeds, something astronomers call a natal kick. The famous Cannonball pulsar is thought to have received a natal kick, and other high-speed stars show us how powerful this blow can be. We don't know the origin of the pulsar smashing through the Snake in this case, but it seems to be doing so with quite some force. The filament is made of magnetic fields along with spiraling particles which are accelerated, causing a filament to glow. Around the fracture, the radio emission glows more strongly, suggesting that the force of the blow warped with the magnetic field distortion of the radio signal. Meanwhile, an enhancement in X-rays near the pulsar is consistent with an accelerated electrons and positrons. The cause of the second, smaller fracture is yet to be determined. There is also more to discover about the pulsar. If it's travelling faster enough, it may someday leave the galaxy. But since it's in the galactic centre, some 26,000 light years from us, it has a long road ahead of it. So, yeah, so there's that video that's been running. But this is, I'll bring up the image that I've got here, which is similar to what you've already been seeing. All right. Okay, just leave that. So that's an actual image. What you're seeing there is an actual combined composite, what they call a composite radio image. So it says here a composite radio, everything in grey, and X-ray is blue, image of the snake and its fractures. So that's a real image taken in different wavelengths, in radio and in X-ray. But what I'm impressed with is that this pulsar that they've detected is spinning at a rate of 500 to 1,000 kilometers per second. I mean, that's just it's just mind-boggling stuff. Anyway, I just thought I'd run that too. All right, here's a bit of a plug for Mount Burnett. Let me just run the caption up on the screen here. I know I've got it here somewhere. There it is. All right, so if you're interested in visiting the Mount Burnett Observatory up in the hills, just visit the website at mbo.org.au. Mount Burnett Observatory, it's mbo.org.au. They've got a public viewing night happening on the 5th of July. And yes, so any more information about the observatory, just visit the website. It's a great little observatory. It used to be managed by the Monash University years and years and years ago, but now a dedicated community of amateur astronomers have now taken it over and are looking after it very nicely. That's the Mount Burnett Observatory up there in the mountains. Astrophys.com.au, they have a new article, Brendan O'Brien, a new podcast, I should say. Astropod, I guess it works. All right, this is the, where is she? There she is. Dr. Anna Nugent, I suppose that's how you pronounce that. Nugent, Dr. Anya Nugent, talking about supernovae, kilonovae, and gamma ray bursts and host galaxies. So that's the latest Astrophys, episode 214, and tune in to astrophys.com, and you'll be able to listen to the latest podcast from Brendan O'Brien. So excellent series that he runs there. Okay, next on the list is yes, we get there now. Okay, all right. Let's run. What I'll do is I'll run this earthquake sequence first. So everybody who's not watching video, I strongly suggest that you go to my YouTube channel, VK3CSJ. Just type in VK3CSJ on. Hang on, let me go back to my camera. Camera, please. Thank you. And just queuing up this video. Where is the video? Where is the video? There it is. No, that's not it. Mumble. It's there somewhere. Oh yeah, okay. Here it is. Now this is courtesy of a fellow. 11 minutes. Have I got 11 minutes? This is a courtesy of a fellow who studies earthquakes, and this is in relation to the Myanmar. You might remember just a few weeks ago, there was a fairly decent earthquake, magnitude 7.7, in Myanmar, which dropped buildings and did some pretty disastrous things. Well, I'm just going to run this video. The bloke he's very quick with what he wants to talk about, because what he wants to do is to show everybody this security camera footage that's come through. And what it is that the whole Earth shifted in this one shot. The camera is looking over somebody's driveway, and as the earthquake starts, the gate in this driveway opens up, but that's the beginning of it. But what you'll see on the outside of this person's property, which has got a road passing through it, passing by the property, the whole Earth shifts 2 to 3 meters in one visual, amazing view. And he repeats the image a few times in talking about it, so you actually see other things happening. There's a transmission power line in the distant background that slowly collapses. There's a few things happening over a house across the road various things that sort of fall down. But it's this dramatic vision of the whole Earth, this whole massive land that shifts by 2 to 3 meters in one fell swoop, and it really is amazing footage. So I'll just bring that up now and see how this plays.
Hey there, team, and welcome to this brief update on the Myanmar earthquake that occurred on March 28th of this year. I covered this earthquake. I'll put a link in the video description to that video I put together where I dive into the tectonic setting, the fault mechanics, and all the data and information that you might want there. The reason I'm doing this video now is a viewer, Keith Farley, and thank you, Keith, for sending that to me, sent me a video footage that is outstanding and spectacular. I've never actually seen anything quite like it. We're actually going to see the movement of the fault take place on a video feed. You're actually going to get to see the ground break and the earth move during this large earthquake. So just to set the table a little bit here, this was one of the biggest earthquakes in the last 5 years or so. I think it's only second to the 2023 magnitude 7.8 earthquake in Turkey. So it's a very large earthquake, very likely that we end 2025, and this is the biggest earthquake of the year globally. Possibly there could be a bigger one, but that that very well could be the case. I'm not going to walk you through all the normal stuff I do with this earthquake because I've done that already, and that video again is for you in the video description. I do, before I get to this really compelling video footage I have for you, I do want to share with you, and I'll put this link down as well. This is a really great summary of that event. So if you want to know more about it, and if you want to kind of deep dive into this earthquake, the USGS has put together a great presentation. This is what's called a story map. They use GIS and lots of data to put together essentially a really nice kind of slideshow PowerPoint type thing, although it's not on PowerPoint, but something quite similar to that with all sorts of information. And so I just want to skim through this a little bit here. They've got some information on the background. And again, you can look at all this and spend more time with this if you'd like to on your own. Talking about the tectonic setting and why we had this fault and earthquake in this area. There's a couple really nice things on here that I do want to spend some time with. There's sort of historic seismicity in the region. You can see the star where this earthquake occurred on March 28th. All the circles are other historic events. Bigger the circle, the larger the earthquake. But they do have a couple things here that I think are pertinent to what I want to show you here in a second. One is that the modeling from this earthquake showed that there was a maximum slip or offset generated by this breakage of rock by this earthquake of about 6 meters, so about 18 to 20 feet or so, right near the main shock epicenter. Further away, the movement was anywhere from 2 to 3 meters. In the video I'm going to show you, based on the amount of slip we're seeing there, it's probably a little bit further away. In fact, I know the location. It's a good 100 or so kilometers, 70 miles or so south of Mandalay, which was near the epicentral area here. So one nice thing that they have on here is this little map over here, and we can actually make this bigger. So this actually runs you through the last 125 years of seismicity in the area. So there's a map of the area, the Saigang Fault, which is the main fault system here. This is not on the plate boundary per se, but it's accommodating a lot of the tectonic motion between these two plates here. And again, I covered all this in a earlier video, but this this fault is again accommodating a lot of the motion. So you can see here you can see the dates here in the top left corner. Here's the earthquakes coming in. So they've got them plotted by magnitude. And this takes about a minute to run through this whole animation, but it's really well done. Colors will change a little bit once they get like a big significant quake. So you can see yellow for the 7.6, and then these sort of regional aftershocks related to that. Big 8.0 down here, probably subduction zone quake along this part of the boundary. So this is just covering seismicity in the area. The main feature, of course, that we're focused on is this fault system here, which produced this March 28th earthquake. But you can see just the seismicity in the area over the past century plus. Again, just letting you know how active this region is in terms of earthquake frequency and also earthquake magnitudes. You know, we do get these 7 and above quakes pretty often. You can kind of see them popping up here, you know, maybe once every 15, 20 years or so, depending on what the averages are. And then we'll get that big one there, big orange one there, right at the end when we had this one. So I liked that a lot. I just wanted to share that with you. Kind of going down through their story map a little bit further. This is a animation of aftershocks. So from this big quake we had in, again, March 28th of 2025, this is going to show the big main event there in blue, a quick aftershock nearby, and this will just run you through all the aftershocks. This is a very short video over, like, I guess about 11-day period following the earthquake. So again, great work from the USGS. There's some really fun stuff here. These story maps are really nicely done, giving you both visuals and text so you can really kind of digest and understand this information. Intensity levels were really high. You can see the elongated regions here, different than what we typically see. We typically see more of a bullseye pattern, but because this was a strike slip fault, the fault was moving the rocks laterally, horizontally, that distributed a lot of the strongest shaking in that north-south direction parallel to the fault, and so you can see that reflected here in the intensity values associated with that earthquake. Then they kind of zoom in, talk about ground deformation. Again, lots of good stuff here. I just don't want to take too much time here because I want to get you to the main event of this video, and I did promise myself I would keep it brief. All the authors to the study, great work USGS, and I'll make sure this link is up there for you. Okay, so without further ado, let me show you this. This is pretty incredible. So what we have here, and I'll share this Facebook link as well. This was the original source as far as I can tell. But basically a security cabin on some sort of, or security camera, excuse me, on someone's cabin or house. And what we want to watch here is you'll see when I play the video, which is about 27 seconds long, you'll see the initial movement of the ground, the shaking caused by the earthquake. But what I want you to watch is right after you see the gate kind of open because of the movement, the fault system runs right outside the property, pretty much parallel to this street, just right outside the fence here. And that's where you're actually going to see the ground break. And because this was a right lateral fault, you'll see that side of the fault on the other side away from the house out there in the middle ground, that will be shoved to the right relative to this side here. So it's really an incredible video. And that was the whole reason for me putting together this video here. So here we go. Let's see, the earthquake begins. Right here, the earthquake's begun. Watch right outside the gate there. And then you see it all just move in a split second. It's really incredible. I've watched it about 30 times now, but I can't get enough of it. So there's the initial movement, the strong waves. Then you can see, maybe about 2 meters or so, about 6 feet of movement just outside the property here, right along the street. A couple other ways to look at it while I kind of run you through this several times. You can watch the cement in the driveway here buckle and break as those earthquake waves come in and they get compressed due to with the shear stress from the fault. You can watch some of the dust come up here once the movement takes place and the ground break off in this direction. Some like object just kind of fell over there. Again, there's so many places to look here. Looks like we have one of the water tanks from someone's house comes down and explodes as it hits the ground, and then the ground breaks. Just incredible. Another good place to kind of focus your attention is just outside the fence on this right side. You can really see there just the ground laterally move. So the movement was mainly on that side. You can also see the power lines going crazy over there. Again, we're watching this several times just because it's so incredible. And I think, as far as I know, as far as I'm aware, this is maybe the first, if not the best, documentation of surface rupture, of ground breaking and offsetting the fault, or the fault breaking and offsetting the ground. I'm too excited to articulate well, that I've ever seen. You can watch this little kind of pagoda, little kind of pergola type thing here, a little shrine, whatever thing, kind of get moved over. The power lines. There's just so much to digest in this. So wanted you to see this. This is going to be just a classic video clip that I will include in my courses to show them how surface rupture works. And this, again, just classic movement of a right lateral strike slip fault. And you can see everything just move there within about a second or so. Once the ground motion kind of hits, things get compressed. Just so much going on here. So yeah, one more time. The water tank. There's just so much to digest here going on. Pretty spectacular stuff. So that was the whole point of the video. Just a quick follow-up from this earthquake in Burma, and just wanted to show you this image and this video here because it's just spectacular, and I think for learning geology and learning, we always get to see, we sometimes feel earthquakes, we always see aftermath and images of what the earthquake did, but it's very rare that people are present right where the surface rupture, where the fault is breaking the surface. People are there to witness it, or in this case, have a video device there to record exactly how that movement took place. So just perfect image here from that security camera looking in exactly the right direction, and just lots of good science going on there. Of course, I don't want to I want to make sure I also recognize this was a very devastating earthquake, and they're still feeling the effects of it. There were something like over 5,400 deaths from this quake and lots of injuries. So I don't want to at all not give enough credence to the humanitarian aspect of this quake, but purely from a science perspective, pretty fascinating video. So just wanted to share that with you. Hope that was helpful and exciting. Thanks for all you do to support the channel, and we'll see you next time, team. Take care.
We have a massive dual filament launch that could give Earth a glancing blow, and a departing region on the sun's west limb fires a big X-class flare and bathes Earth in a radiation storm. Those stories and more are in the news this week. If you want to learn how weather from our star causes impacts at the Earth that shape the future of our world, join Professors Dr. Jenny Meehan, Michael Cook, and myself as we guide you through a space weather certificate program like no other. To enroll in the Space Weather and Environment Science program offered at Millersville University, go to millersville.edu/SWEN. It's weather for the 21st century. This forecast also sponsored in part by CW Ops. Space weather this week continues to give us some great eye candy, but there's not been a lot that's been Earth-directed. As we take a look at our Earth-facing disk, we have been paying attention to region 4079 and 4086. We were hoping that they would give us some really good flares while on the Earth-facing disk, but it really hasn't manifested until later. We'll get back to that in a second. We've also been hoping to get some fast solar wind from these coronal holes, but that also hasn't manifested all that much. All we've been getting is a bumpy ride over the past few days. But the interesting thing is that take a look at these long filaments, especially this one right here. This one, starting around the 11th, really started getting active and began to really get activated and lifted off. You'll see it whoosh, along with another filament. We'll see it here in close-ups. You can actually see this little tether right here kind of break off. And as soon as it breaks off, this whole thing begins to lift off. And you'll see another filament on the sun's far side. And they kind of lift off as like these gorgeous bird wings. Watch this. It's just absolutely stunning. Just the sheer size of these two filaments lifting off. Look at that. Just unbelievably beautiful. But on top of that, you'd think that this was just going northward, but believe it or not, the scar from this thing, as it lifted off the sun, you can see where it tore off the sun. We changed color here, and you can actually see the scar burning clear down in here, which makes us think, well, maybe there's part of this that's Earth-directed. In fact, when we take a look at coronagraphs, you can actually see this. It's not really a partial halo, but watch this lower edge here keep creeping down. That's almost mid-disk here. So we could get a glancing blow, and we'll talk more about that as we take a look at prediction models. Meanwhile, as we look back at the disk, believe it or not, region 4086, finally, watch it here. Pow! Look at that gorgeous eruption. This was a massive eruption. It was actually an X 1.2 class flare and caused an R3 level radio blackout on the western hemisphere. You can see it right there. It also caused a really big eruption you can see along with the radiation storm. Look at that thing right there. So we've got some decent activity, and it's continuing to be active on the sun's far side, and we'll talk more about that in a little bit here. Meanwhile, what we're going to get ready for next week is that this coronal hole is returning into Earth view, so that could give us some more chances for some fast solar wind. And we've got not just this region, but another two regions rotating into Earth view over the next maybe 3 to 5 days. And those regions look like they're growing pretty fast on the sun's far side, and we'll talk more about that in just a moment. Now, switching to the far side of our sun, this is stereo A, and we're back to looking at stereo A because it's actually moved to the sun's far side, just off to the edge of Earth anymore. So here's Earth, here's the sun, and here's stereo A looking at the sun just a little bit from the side. And as we kind of calibrate ourselves, you can see region 4079 and 4086. These two regions are the ones that are actually being very active on the sun's far side. In fact, as they rotate to the sun's far side, it's really region 4086 that continues playing pretty hard here, and expecting to see probably more big solar flares from it. And now switching to our full sun map, luckily we have SDO AIA, that's Earth side, so we can get an idea. That's what we see here in red. But we also have solar orbiter EUI imagery of the sun's far side, because solar orbiter is on the sun's far side right now. That gives us a whole sun idea of what kind of active regions might be lurking and growing on the sun's far side. And as I set this in motion, you can see region 4079 4079 and 4086. That should calibrate you a bit so you know that's Earth side. But then on the sun's far side, you can see region 4064. This is the region that has just rotated into Earth view and has become region 4087. But we also have a new region developing right there, as you can see, that has yet to rotate into Earth view. And if you watch region 4073, it's also being a bit active. So it's growing a little bit there. So we expect to have more activity here over the next couple days. And then again in about 3 to 5 days as some of these new regions rotate back into Earth view and, of course, are firing off big solar flares. So amateur radio operators and emergency responders expect to have more activity rise here over the next maybe 3 to 5 days, including bigger chances for radio blackouts and, of course, more noise on the dayside radio bands. Now, returning to that partial Earth-directed filament eruption that we saw earlier with the big bird wings, we switched to our solar storm prediction model, ENLIL. Now, this is NASA's version of the model. You're looking down at the sun from the North Pole with Earth being off to the right. Now, as I set this solar storm model in motion, you're going to see that solar storm barely be launched. You can see it a lot better here in the vertical cut because that solar storm, remember, was launched pretty much northward. But believe it or not, there's a little bit of something that looks like it's going to graze Earth right around early on the 16th. In fact, when we take a look at our impact footprint here, you can see it's just going to be on the north side of Earth. This is north pointing this way. So this is just north of Earth. So we could get a bit of wake from this structure as it passes by. If it's any larger than, I mean, this thing's pretty big. So the chances of it being large enough to give us some type of disturbance is pretty good. So aurora photographers, if you're at high latitudes, well, you could get a little bit more of a bumpy ride than what we've been given. Not expecting to get a whole lot from it, but it might be worth a look. Now, stepping outside to take a look at our current conditions with our global geochron map, you can see we're actually dealing with a bit of a radiation storm, and this was due to that R3 level radio blackout that we had from that X-class flare, but it hasn't been all that bad. We haven't reached S1 levels, but we might here over the next day or two, so we have to be a little bit careful. You amateur radio operators are likely dealing with a little bit of noise on the bands, and those who are dealing with GPS reception know that you might have issues with navigation at the high latitudes here over the next couple days. Now, as we take a look at aurora, well, we haven't been getting any big solar storms Earth directed, but we have been getting a bit of a bumpy ride, a lot of just little disturbances here and there, and that's caused the aurora to build just a little bit, but it's been reasonably mild. So again, high latitude stuff just a little bit. Now, you'd expect that that would affect our scintillation risk for higher frequencies like GPS, but according to the ROTI scintillation risk map, you know, we're not seeing stuff at high latitudes, all things considered. It's just kind of random here and there. So all things considered, you GPS users, well, as long as you stay away from dawn and from dusk, your risk for scintillation shouldn't be all that bad. Now, switching to our moon, we are now passing through the full moon phase on our way to a third quarter, and by the 20th, the moon will be about 50% illuminated. So you night sky watchers, if you want to catch those dim objects in the sky, well, you're going to have this bright companion, so you're going to need to check your local rise and set times. Now, switching to our solar storm conditions and aurora possibilities over the coming week, we are dealing with a bit of a solar storm hit right now. It's not a very big one. It looks like it's mostly kind of a glancing blow, but it has been giving us a bit of activity. At high latitudes, we're expecting minor storm conditions, but things should kind of settle down. We might get a little bit of fast solar wind, but then that glancing solar storm that we expect from that big filament eruption, that's going to be hitting around the 16th. We could have up to about a 20% chance of a major storm over the next day, and then things will settle back down, and once again it's going to be nothing but just kind of like this bumpy ride. So aurora photographers, if you're high latitudes, don't expect a massive show, but you could get a little something from this, so it might be worth a look. Now, as we switch to mid latitudes, well, we're only expecting unsettled conditions, but we could have up to about a 15% chance of a minor storm starting around the 16th, because we're expecting that dual filament structure to kind of graze Earth right around the 16th. So aurora photographers, if you're dedicated, it might be worth taking a look. Otherwise, you might want to sit this one out at mid latitudes because it's likely not going to be all that exciting. And now switching to our solar flare and dayside radio blackout outlook over the coming week, we are sitting in the low 100s for solar flux, and that means that we just don't have a lot of active regions that are giving us a lot of solar flux on the day side. That nice thing is that it gives us a lot of respite when it comes to big noise on the dayside radio bands. We're sitting at minor noise levels with only about a 15% chance of M-class flares at the R1 to R2 level, and only about a 1 to 5% chance of X-class flares, because the region 4086 is now rotated to the sun's far side. Now, likely that's going to continue throughout the rest of this week, but we might see as we go into Sunday and into next week, some of those other regions are rotating into Earth view, so we could see a pickup when it comes to big solar flares. So dayside is nice and quiet this week, so enjoy, amateur radio operators, but expect next week things will pick back up again. And now switching to our radiation storm and polar aviation outlook over the coming week. Right now we're sitting at the D2 minor range. This is at flight level 360. It's also the S0 stormy range for everyone else. We're not quite at the S1 level for radiation storm, but NOAA's giving us about a 70% chance of hitting that S1 to S2 level over the next 24 hours. And that's going to continue to be a risk over the next couple days. It depends upon how quickly that non-Earth directed solar storm that was launched along with that X-class flare, how long it takes for that to kind of clear the area. So expect that you're going to have elevated dose rates until about the 16th, and then things should calm down. So you high-risk passengers, and this does include air crew and frequent flyers, please take this into consideration in your flight plans, and then keep an eye on those ICAO advisories. So the space weather this week is very interesting. We don't have a lot of Earth-directed storms headed our way, just kind of a bit of a bumpy ride. But we had that gorgeous, massive filament eruption. So your aurora photographers, if you're at high latitudes, right around the 16th, you definitely could get a boost in the aurora. So it might be worth a look. Aurora photographers at mid-latitudes, well, only if you're dedicated, right? I say it all the time. Now, amateur radio operators and emergency responders, well, this week things are getting a bit quieter. You should enjoy a little bit more, quiet on the dayside radio bands and less radio blackouts. Although in about 3 to 5 days, things are going to pick up again. So just be aware of that. But right now, enjoy the quiet. And now you GPS users, well, we're only going to have a bumpy ride. There hasn't been a lot of aurora going on, and we're not having a lot of big issues with radio blackouts. So right now, it's just high latitudes with that radiation storm, and once it dies down in a few days, your GPS reception should be absolutely golden. I'm Tamitha Skov, the Space Weather Woman. Thank you for watching.
Audio, there we are, back on there. All right, thank you, Tamitha, and I hope you found the earthquake sequence of interest. Let me just check my audio on 80 meters. Where am I? 121212. I guess that sounds okay. Oh, it's just 12. Yeah. All right. Well, it's 7 past the hour, so normally I would finish off with a quick rundown of spaceweather.com. They actually have an interesting thing there too, actually. Let's see, just quickly, this is the current disk of the sun. If you could see it right now, it's only really 1 or 3 solar flares that are there, and the coronal hole is what Tamitha was just referring to. That's now coming around into view. Some high charged particles are streaming from that region of the sun. And this is the current auroral glow over Antarctica. So there's a little bit happening, but not. I don't think there'll be much in the way of aurora actually occurring, unless you're down in South Tasmania there, perhaps. Let's see what else. The sunspot number is currently 45. The radio sun is currently 119 solar flux units. The KP planetary index is 3. Over the next 24 hours, it's going to be still 3, considered quiet. And there's just a couple of references here to aurora on Mars and Jupiter, amazingly enough. Yesterday's X 2.7 class solar flare has hurled a CME into space. It won't hit Earth, but it will hit Mars, according to the NASA model. The CME will reach the red planet on May 18 and impact the impact could spark a global auroras on that planet, which will be interesting. And erode a small amount of the planet's carbon dioxide atmosphere. Same thing with Jupiter. NASA James Webb Space Telescope has discovered a new type of aurora fizzing and popping on Jupiter. Unlike auroras on Earth, which come from oxygen and nitrogen, Jupiter's arise from completely different compound, ionized trihydrogen, H3+. Trihydrogen is one of the most abundant ions in the universe, and it is common in the interstellar space and has also been found in the cloud tops of gas giant planets like Jupiter. The atomic structure of H3+ causes it to glow with an infrared light, and it is involved in aurora producing space storms. That's the reason why James Webb Space Telescope can see it. Trihydrogen auroras have been seen before, especially on Neptune, but these auroras on Jupiter are different. So there is a little video that runs with that, but I won't worry about that right now. In fact, if you just go to spaceweather.com right now, you'll be able to click on that video that they've got. So as of May 16, 2025, there were 2,349 potentially hazardous asteroids, but none of those asteroids are on collision course with Earth. All right, so that's spaceweather.com in a nutshell, and I want to acknowledge Mike, VK3PI, who's been watching, and if I go to the Discord, there were a few folks listening tonight. G'day Andrew, VK3KIS is there, and Steve, of course, VK3SBX. Mike 3XL was there as well. He's disappeared, and Brett VK2CBD's also disappeared from there. So, but there were a few. So I was going to try and finish up early tonight, but look at that. I didn't think it would. Anyway, all right. Now I'll just take a quick listen on 80 meters and see if there's any stations wishing to check in. I'll just get rid of these headphones first and do that, and I should be able to hear the speakers. All right, this is VK3EKH listening on 3541.
VK3 Hotel Kilo, VK3SPX.
Okay, acknowledging VK3AOB, VK3HK, VK3SPX. Anybody else?
VK3 BKO.
VK3BKO, was there another station there? All right, that's okay. To the top of the list, g'day Brett, VK3AOB, VK3EKH.
Yeah, g'day Clint, and fellow listeners and watchers. Yeah, I've got the stream happening. That's fascinating, the way the Earth actually moves in the mind mapping. Yeah, it's awesome. You wouldn't want to be standing astride either side of...
No.
Especially if you'd open up, maybe 3 metres, it wouldn't be scary enough, but if it was 30 metres, you'd be somewhere down a deep hole. But anyway, there you go. Yeah, good broadcast, you're doing well. And I forgot, it was 25 past 10, right? I was sitting here watching the football, and yeah, so there you go. Yeah, back to you.
Yeah, no worries, Brett. VK3BAOB, VK3EKH. Not a problem, dear sir. Thank you for watching and just coming in at the last point. Yeah, the football's been running over my shoulder there, keeping it. I don't know who won, but nevertheless, it's been there. Yeah, it is amazing footage. I'm really, really impressed by it, and
video clip.
running it again on the video. What impresses me is just the way that massive amount of earth just physically moves, and you can see the tear in the ground in the driveway of the house across the road. It starts off as a flat surface, but the whole thing just tears, and things fall down and shake, and the transmission line in the background there on the right side just collapses. It's a scary stuff. I actually did detect that earthquake here. I was up when it occurred. There's a website called Global Quake. It's actually it's on YouTube. If you go to YouTube and type in Global Quake, you'll get a real time. Somebody's just broadcasting Global Quake on YouTube all the time. But it's a program, and you can download it free, and it'll run on your computer, and it gets data, real-time data from hundreds and hundreds of seismometers around the world that are just connected to the system. So if there's an earthquake occurring anywhere, the system automatically sends an alarm, and the graphic of the Earth zeroes in on where that earthquake is, and of course, this earthquake in Myanmar, I saw it actually happen in real time. And what this program does is it sends out a concentric circle of energy. It's the P wave, and it emanates from the epicenter, and it just goes out slowly. It's actually traveling at hundreds of kilometers an hour, but it's emanating out, and as this pressure wave comes into Australia, it starts tripping seismometers around Australia. And of course, I've got an old seismometer that sits on the floor here in the barn, and as this pressure wave went across Melbourne, all of a sudden my own seismometer started detecting these pressure waves, and I had my mobile phone. I'm videoing it with the camera, and I've been meaning to edit down all that I recorded at that moment that earthquake occurred. So it really is fascinating stuff. But by the same token, it's really scary stuff if you were to experience something like that. And even worse, for those people that are directly affected by such amazing forces. So yeah, impressive stuff, isn't it? Really, really impressive. Anyway, all right, it's across to Mr. Steve, who's probably in bed. VK3HK, VK3CSJ, EKH.
Well, actually, no. I'm sitting up in the radio department. You're belting in here. This is the strongest I've ever heard you, Clint. 35 over 9. Not all the time, but peaking up to that. And yes, that earthquake, mamma mia. I've downloaded the video. It's on Wiki, what's it called? Wiki something. Anyway, all you have to do is type in stuff about Myanmar 7.7 and bang, up it comes. Yeah, I've played it, I think I must have played it about a dozen times so far. Each time I look at it, I see something different. As you say, the transmission towers over to the back right, they collapse. And the guy's brand new pavement, it's all cracked. And his security gate isn't very secure anymore. Oh boy. Yeah, anyway, thanks very much for that, Clint. It was a ripper. Good broadcast. VK3EKH. This is VK3HK.
Yeah, no worries, Steve. Thanks for staying up and listening as well. And I always try to make it interesting. Although I could probably have chosen some very quicker articles at the beginning there. But I don't know. These things take more than 5 minutes to read out. So there it is. Anyway. All right. Yeah. I was just impressed to be able to detect it here. Normally, big earthquakes in the magnitude 7 area, I see thousands of kilometres away. But if we have a local earthquake that's about 2.5 or 3 on the Richter scale, I rarely see that here in this location unless it's really local. So, but look, this seismometer that I've got, it's not a, I mean, it's using a geophone, but it's not a professional seismometer. It's a geophone that's been interfaced to a bit of circuitry which converts the signals to a RS-232 port, and I mean it works. But I have plans to bury it in the ground outside in the near future, because it's currently sitting on the concrete slab, so it's prone to all sorts of vibrations. So if I can bury it in the ground down near the observatory, it'll be far better down there, I think. So we'll be doing that in the near future. Anyway, all right. Thanks, Steve. I won't be around tomorrow morning for the Saturday morning net because I'm working. I've been asked to come in at 6 o'clock in the morning, so I'm starting work at 6 and finishing at 2:30. So I shan't be about at 11 o'clock, just in case. Steve, VK3SBX, VK3EKH.
VK3EKH, this is VK3SBX. Hello, Clint. Yeah, it was amazing, wasn't it? The track footage, I hardly agree. I think that transmission tower probably happened to this quite spectacular. First job I ever had was designing data logging equipment for
going on. Pretty spectacular stuff. So that was the whole point of the video. Just a quick follow-up from this. As far as I'm aware, this is maybe the first, if not the best, documentation of surface rupture, of ground breaking and offsetting the fault, or the fault breaking and offsetting the ground. I'm too excited to articulate well, that I've ever seen. You can watch this little kind of
okay, thanks for the broadcast, Chris. Good stuff as usual. VK3EKH,
Yeah, thanks, Steve. Good on you. VK3SBX, VK3CSEKH returning. Yeah, look, I will. I've already discovered that it's very cold being in the observatory. Last Sunday, I moved the Celestron scope down in there, which has cleared up a little bit of space over here. That was one of the main reasons why, once the dome was done, I thought I've got to move the telescope down there. So I've got the Celestron 800 or 8-inch down there at the moment on the tripod. So I can't be serious about experimenting with any pictures at the moment because it's on the tripod. I'm still waiting to get the 600mm PIA from Sidereal Trading. That'll be probably sometime next week. That'll arrive, and once I can bolt that to the concrete pillar or plinth, I will then mount the NEQ6 Pro Equatorial mount motor drive. I am seriously thinking of deforking the Celestron, it just might make a few things a little bit easier. I'm still making up my mind about that, but I might do that. I might defork the Celestron, taking note of how that happens, and get a dovetail and fix that to the mount. That just might solve a few things that might create a bit of a problem initially elsewhere. Because I was originally thinking of removing the Celestron from its tripod and mounting that directly to the pier, but I would need to get a adapter plate made to go from the base of the Celestron to the pier, and it just might be a little bit easier in the process actually to actually defork the CPC 800 and put a dovetail on it and do it that way. It's conceivable. So just a thought. Anyway, I know there are videos on YouTube that show or talk about deforking, so it's been done before. Anyway, we'll think about that. And the dew, yes, because I'm only a few meters away from a creek, and the humidity factor is perhaps a little on the high side down the far corner here. So I'm going to have to definitely investigate a method of keeping the moisture off the front of the telescope. So certainly a dew shield will be purchased. I know you can make those up fairly easily, I suppose, but I'll get a proper dew shield and a heating element that can be used. If I have to use fans, I'm a little bit worried about the vibration that the fan might cause. There might be very subtle vibrations that might affect photography, but you didn't really say anything about that, so maybe it's okay. Yeah. So, and of course, I want to get a full suite weather station for the dome as well. So anemometer and cloud and rain sensors and all that sort of stuff. But no, look, I've only been there a couple of times now. I was mucking around with the Celestial app, the mobile app, and I was trying to communicate with the Wi-Fi sensor, and for the life of me, I couldn't get communication to start. So I need to go back down there and muck around with it. But it was 6 o'clock last Sunday, and mosquitoes were starting to make an appearance, and I could really feel this cold, and I thought this is no good. I'll close up and go inside and make dinner. So yeah, I'm going to have to really adjust to. Well, this is why I want to automate everything. I want to stick a camera on the telescope and do all my functionality from upstairs in the astronomer's room where it's nice and warm. So anyway, we're getting there. All right, it's Costa Brennan. I think it is Mr. VK3BKO, and thanks for hanging around there, Brendan, and good to hear you too. VK3BKO, VK3EKH.
Yeah, VK3EKH, VK3BKO. Thanks, Clint. I'll be quick, mate, because I know you want to go to bed. Got to get up early. I know what that's like, mate. I do it every day. Yeah, fascinating, mate. Really good stuff there tonight, and thank you so much for pulling all that together, mate. You do a great job week after week, and it's highly appreciated, mate. I really love the the earthquake, mate. That was absolutely amazing, mate. You can see the plates just shift there.
Pagoda, little kind
I
of
know it's only a second.
pergola type thing here, a little shrine, whatever thing, kind of get moved over. The power lines. There's just so much to digest in this. So, wanted you to see this. I mean, this is going to be just a classic video clip that I will include in my courses.
Collapsed over in the top corner there. I didn't see that until he pointed it out. But yeah, there's a lot going on in that video, that's for sure. Really, really interesting.
Is to show them how surface rupture works. And this, again, just classic movement of a right lateral strike slip fault. And you can see everything just moved there within about a second or so once those the ground motion kind of
news that they got the thrusters going again. So yeah, but you never know. We might be able to power that on for a little bit longer, into deep space. That's fascinating as well. I'm always interested in what's happening with the Voyager satellites. First piqued my interest in with Star Trek, mate. And all those years ago, and yeah, but you know it's real. Yeah, but anyway, good on you there, Clint, and thanks for a great show, mate. And yeah, go to bed, mate. And yeah, tough luck on having to work on the Saturday. Anyway, good on you there, Clint, my friend, and have a great weekend. VK3 EKH and the group VK3 BKO.
Good on you, Brendan. VK3 BKO, a local ham. VK3 EKH returning, very good. Yeah, thanks, mate. Oh, and it is, and as the fellow in his YouTube report was saying, that this is probably the first time that such a dramatic video of a lateral shift in the Earth has actually been caught on video so dramatically. So, but he as he said, this is quite a few. Like 100 kilometers or so from where the activity was, because apparently the shift was much further, closer in the city area where it happened. Apparently things shifted by anything up to, say, 20 meters or something like that. So can you imagine that image that we've been seeing there of the land moving probably by about 20 meters or so? I mean, it's scary. I mean, it's just... You just can't imagine a huge mass of Earth just suddenly shifting like that. But that's what happens at ocean floor all the time, where the tectonic plates are constantly applying pressure, and the ridges at the bottom of the sea, they shift all of a sudden, and hence that's where we get our tsunamis from. So the amount of energy that's just suddenly released by these massive shifts in the Earth's crust is just staggering, and certainly the shift in the Earth's crust that occurred at the tsunami that damaged Indonesia 10 years ago or so, that changed the Earth's mass to some degree, and the Earth's rotation was, I think, slowed down, not only by a few milliseconds, but it was slowed down as a result of the change of mass in that area. Something along those lines, anyway. Pretty amazing stuff. I noted with interest. I think it was on Facebook. There was Bruce Springsteen. Bruce Springsteen's been doing concerts in America, and there's a person that made a comment on the Facebook page where he's having a bit of a go at Trump. I don't know if I can find that very quickly. Probably not. But somebody reported on the fact that somebody was wearing a T-shirt that had a statement on it. I don't think I'm going to find it quickly enough, but it had a statement that said that something along the lines of the Earth is getting tired of humans it's something along that line, indicating that it's time for the human race to be wiped off the planet. And it was just some sort of statement like that, saying that the Earth is getting tired of humans on the planet. I can't remember exactly what it was. Now I'm just trying to quickly find it, but it's not there. Anyway, it doesn't matter. But it was rather interesting. Not that I would go around wearing that kind of T-shirt either. Anyway, all right. This is VK3 Echo Kilo Hotel. We'll just take one more listen if there's any other stations wishing to quickly check in. VK3 EKH listening. All quiet. As Randall would say, they said no. Good old Randall. Anyway, all right. Cheers, everyone. Thanks for listening in this week again. And we'll be back next Friday with another range of interesting articles and videos and whatnot. So this is VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria. Any information about the ASV, just go to the website at www.asv.org.au. We've been broadcasting since 1988, so we'll continue doing it for a little bit longer, but how much longer is a question mark. We'll see. We say cheers for now, and have a nice weekend, folks. This is VK3 EKH with VK3 CSJ on the microphone, going clear for now. Cheers, everyone.
Yes, Chief. If you've got to work, you better get into bed. I had all the preamps on. You were hitting plus 60 dB, and I've turned them all off. You're plus 30 to 40. Amazing. Talk to you next week.
Yeah, thanks, Brett. Steve, you were also making a comment, VK3SBX?
Oh, yeah, I was just going to comment, just to follow up on our comment before, just for a minute or two, but do you want to close the YouTube first?
Oh, yeah, I'll just do that. Hang on a sec. Where's my stream? There's Discord. Discord's okay. I'm not worried about Discord. Where's my vMix? There it is. All right. So everybody watching on YouTube, cheers for now. We'll see you all next Friday with a bit more of the nonsense that goes on here. So we shall go to test pattern and close the YouTube stream down. So cheers for now, and don't worry about subscribing. Don't worry about clicking the bell. That's just a lot of nonsense. And of course, with that attitude, you'll never see a 1 million subscriber YouTube thing on the wall behind me. Anyway, stand by and kill the audio just for a second.